3. ABAC Enterprise Considerations. Many factors must be considered before deploying an ABAC system across an enterprise. This section addresses consolidation of available guidelines based on the state of the technology to date and lessons learned through multiple attempts within the federal government to deploy ABAC capabilities throughout a large enterprise. The guidelines are presented according to the phases of the NIST System Development Life Cycle (SDLC), illustrated in Figure 6. For more general information regarding the definitions of the phases and expected outputs, refer to NIST 800-100. Most considerations for employment of enterprise ABAC fall within the first 4 phases: initiation, acquisition/development, implementation/assessment, and operations/maintenance. This section focuses on those phases exclusively. The development and deployment of an enterprise ABAC capability requires the careful consideration of a number of factors that will influence its design, security, and interoperability. These factors lead to a set of questions that should be considered. Establish the business case for ABAC implementation. What are the costs of developing/acquiring new capabilities and transitioning away from old capabilities? What are the important benefits provided by ABAC? What new risks, if any, are introduced by ABAC? What new governance structures are required to manage shared capabilities and documentation of policies that were previously human-in-the-loop decisions? Which datasets, systems, applications, and networks need ABAC capabilities? How is liability for data loss or misuse of data managed? Understand the operational requirements and overall enterprise architecture. How are privileges managed, monitored, and validated for compliance? What interfaces and objects will be exposed by the enterprise for information sharing? What ACM will be used? How will subject and object attributes be shared and managed? What are the access control rules and how are they captured, evaluated, and enforced? How is trust managed within the enterprise? Establish or refine business processes to support ABAC. Are access rules and policies fully understood and documented? How are required attributes identified and assigned? How are multiple policies applied in a hierarchy and deconflicted? How are access failures handled? Who creates new policies? How are common policies shared and managed? Develop and acquire an interoperable set of capabilities. How will interoperability be achieved? How are subject attributes from identity management integrated into ABAC? How are diverse or special needs for identities handled? How are subject attributes shared and maintained across enterprise entities? What are the trade-offs with centralization versus distribution of authentication, authorization, attribute management, decision, or enforcement capability? How are environment conditions used in access decisions? How is confidence in security, quality, and accuracy measured, conveyed, and used in access decisions? How are subject attributes mapped between organizations? How are policies developed to incorporate the latest set of available subject, object, and environment condition attributes? Evaluate performance. How are subject attributes managed for disconnected and bandwidth limited or resource limited users? How available are interface specifications for new participants to the enterprise? How are quality and timeliness of changes to attributes and policies measured and enforced? Will overall system and end-to-end performance be adequate? The following sections address these principles and questions in more detail. 3.1 Initiation Phase Considerations. During the initiation phase, the organization evaluates the need for an ABAC system and its potential use. It should be determined whether the ABAC system will be an independent information system or a component of an already defined system. Once these tasks have been completed, and a need has been recognized for ABAC capabilities, several processes must take place before the ABAC system is approved, to include clearly defining goals and defining high-level requirements. During this phase, the organization defines high-level business and operational requirements as well as the enterprise architecture for the ABAC system. 3.1.1 Building the business case for deploying ABAC capabilities. As with any major system deployment, the deployment of enterprise ABAC capabilities should be preceded by significant requirements evaluation, trade studies, and planning activities to include the determination of whether ABAC is the right type of access control capability needed and feasible given the application portfolio. ABAC has the virtue of providing access without prior knowledge of or information about the subject, and large-scale enterprise information sharing of a limited set of mission or business-critical objects. Before any technical requirements are generated or deployment decisions are made, it is important to evaluate and establish a business case for the deployment of ABAC capabilities as well as to define the scope of the enterprise targeted for these capabilities. Enterprise ABAC carries with it significant development, implementation, and operations costs, as well as a change in the way enterprise objects are shared and protected. Case studies or experience reports from other organizations may be helpful in planning the ABAC deployment. It may be more practical to take an incremental approach and implement ABAC protections for a limited set of objects. This implementation would establish and utilize, to the maximum extent possible, policies and attributes appropriate for the enterprise as a whole. Feedback from incrementally building out this ABAC capability will refine policy and attribute definitions and exercise the governance and configuration management capabilities necessary to support broader ABAC use throughout the enterprise. It should be noted that without addressing the issues presented in the following subsections, an enterprise may incur significant delay and additional cost in its ABAC deployment. 3.1.2 Scalability, feasibility, and performance requirements. Scalability, feasibility, and performance are important issues when considering the deployment of an ABAC product or technology. Enterprise ABAC, allowing an organization to have access to authorized objects managed by another organization in the same enterprise, requires complex interaction between ABAC components. Often these components are distributed throughout the enterprise across organization boundaries and sometimes on different networks. The larger and more diverse the enterprise, the more complex these interactions become. What may have been a simple request to access a document in a repository may now require a policy request from an enterprise service, multiple attributes from numerous logically and physically dispersed attribute sources, a third-party validation of the integrity of the object attributes bound to the document, and a decision made at one point in the enterprise while the enforcement of that decision occurs at a different point in the enterprise. Feasibility evaluation should check whether applications can support ABAC, either natively or through third-party applications. All of these potential interactions have a performance cost that must be evaluated when determining the scope of objects that may be shared through an enterprise ABAC implementation. To mitigate potential performance and scalability concerns, a variety of architectures should be considered. The distribution of ABAC components should take into account the underlying enterprise architecture and location of necessary data and objects to be shared. For instance, PDPs and PEPs may be deployed under the same administration. 3.1.2.1 Development and maintenance cost. While ABAC provides many important new features when deployed across an enterprise, the cost of development, deployment, and maintenance of ABAC may exceed its benefits in the long term. In addition, the cost of retrofitting applications to use ABAC is wholly separate from procuring, setting up, and maintaining an authorization infrastructure. While cost savings can be incurred through no longer having to maintain existing solutions, it is possible that a large portion of that maintenance savings will be offset by the cost of managing and maintaining subject attributes and the policies needed for ABAC, as well as additional system support required. The benefits of having more precise, consistent, and flexible security must be quantified and used to determine the right balance between cost of risk and cost of security. Given these considerations, ABAC is not the right solution for every access control problem but can prove viable for environments where subjects and objects carry a rich set of attributes and access decisions involve complex relationships among these attributes. 3.1.2.2 Cost of transition to ABAC. Attributes and rules allow more precision through a larger number of discrete inputs into an access control decision, providing a larger set of possible combinations of those variables to reflect a larger and more definitive set of possible rules, policies, or restrictions on access. ABAC allows a large number of attributes to be combined to satisfy any access control rule imaginable. As long as the attributes are available to evaluate at the time the access decision is rendered, the rule can be as complex and definitive as it needs to be to satisfy the protection requirements of the object. Thus, fine-grained AC allows access to be more detailed or flexibly partitioned when compared with coarse-grained AC. For example, coarse employees can read file X, fine employees working on Project A can read file X, and finer employees working on Project A during office hours can read file X. The governance and business process changes that must accompany the shift to ABAC represent a significant transition to an approach where objects are controlled by enterprise-governed policies and enterprise-controlled attributes, and sometimes local control as well. These objects may now need to be associated with an additional set of characteristics that may not have been used in access control until now. Users accustomed to logging onto their network and having broad access to resources may no longer have that luxury. While policymakers will do their best to reflect current mission and business needs in policies, there will be unexpected but inevitable denials of access to those with critical mission or business functions. As ABAC products are implemented and an organization's access control changes, new processes and capabilities will need to be integrated into the user's day-to-day business processes and enterprise policies. During the transition, it will be important to ensure that users understand why these access control changes are being implemented and what impact they will have on the way business is done. These users will need to be educated in the new ABAC systems and processes. These changes need to be properly communicated to show the benefits of an enhanced user experience, the enhanced security and safeguarding of critical information, the requirements of the new ABAC system, and the legacy access control systems. If replaced, that will be phased out. Users may be comfortable with existing processes and may not see an immediate value in switching to an ABAC capability. It may be important to emphasize areas in which ABAC enhances the security posture of the enterprise in contrast to areas where it complements existing access control mechanisms. 3.1.2.3 Need to review privilege and monitor authorizations. Some enterprises may desire the ability to review the capabilities associated with subjects and their attributes and the access control entries associated with objects and their object attributes. More succinctly, there are some requirements to know what access each individual has before the requests are made. This is sometimes referred to as before-the-fact audit. Before-the-fact audit is often necessary to demonstrate compliance to specific regulations or directives. Another commonly desired review feature is determining who has access to a particular object or to the set of resources that are assigned to a particular object attribute. An ABAC system may not lend itself well to conducting these audits efficiently. Rather, a key feature of ABAC is the ability of the object owner to protect and share the object without any prior knowledge of individual subjects. Evaluating the set of subjects that have access to a given object requires a significant data retrieval and computation effort, possibly requiring every object owner to run a simulation of the access control request for every known subject in the enterprise. Limiting the scope of ABAC implementation can help in predetermining access authorizations, but other methods of ensuring the validity of access authorizations should be explored if the enterprise requires such validation. 3.1.2.4 Understanding object protection requirements. Within the various parts of an enterprise, there are a number of different operation and object types over which policy needs to be enforced. These may include operating systems, applications, data services, and database management systems. While some NLPs may exist to help determine authorized access, access to most objects is controlled through local group policy governed by local business rules, undocumented evaluation factors, and inherited non-standard doctrine. Implementing ABAC requires, first and foremost, a thorough understanding of the objects and their protection requirements. Without that understanding, the cost to develop and implement the technology required for enterprise ABAC increases dramatically. It is recommended that enterprise ABAC implementations be initially applied to objects that are well-defined, controlled, and documented. 3.1.2.5 Enterprise Governance and Control. Successful enterprise ABAC requires the coordination and determination of several business process and technical factors as well as establishment of enterprise responsibilities and authorities. Without the proper governance model in place, organizations will develop stovepipe solutions and enterprise interoperability will be delayed significantly. It is recommended that an enterprise governance body be formed to manage all identity, credential, and access management capability deployment and operation, and that each subordinate organization maintain a similar body to ensure consistency in managing the deployment and transition associated with enterprise ABAC implementation. Additionally, it is recommended that the governance body develop a trust model that can be used to illustrate the trust chain and help determine ownership and liability of information and services, needs for additional policy and governance, and requirements for technical solutions to validate or enforce trust relationships. The trust model can be used to help influence organizations to share their information with clear expectations of how that information will be used and protected, and be able to trust the information coming from other organizations. Additionally, enterprise authorization services should be tightly integrated with security audit, data loss prevention, security configuration management, continuous monitoring, and cyber defense capabilities. Authorization services alone are not enough to ensure the security needed to protect the mission-critical objects resident on the networks. Efforts should be undertaken to fully understand enterprise security requirements and the impacts an ABAC implementation will generate. For example, when using a distributed ACM architecture, there may be consequences to the ability to audit access control decisions and events. ABAC systems can benefit from deployment in environments governed by a trust framework. A comparison of representative trust chains for legacy ACLUs and ABACUs, Figures 7 and 8, shows that there are many more complex trust relationships required for ABAC to work properly. ACLs are established by the object owner or administrator, who ultimately enforces the object access rules by provisioning access to the object through addition of a user to an ACL. In ABAC, the root of trust is derived from many sources, such as subject attribute authorities or policy developers. When managing the risk inherent in information sharing, two perspectives of risk must be addressed when deploying an enterprise ABAC solution. First, an ABAC solution may be considered one of many security control options that help protect an enterprise from risk. The risk of unauthorized access to protected resources can be reduced with an ABAC implementation because precise policies can be implemented consistently and updated more easily to address changing threats. Second, use of ABAC may increase or decrease operational risk of an enterprise by exposing protected objects to access by unknown entities. By assuming that attributes are issued appropriately, the ABAC system is partially dependent upon the attribute issuing authorities. This multiplicity of risk sources presents a number of challenges that must be managed through governance and a formal trust model. When establishing a governance model for managing the risks inherent in ABAC, it is important to ensure there are mechanisms and agreements in place with each responsible organization to monitor and manage these roots of trust and any liabilities that occur as a result of unwarranted access. 3.1.3 Developing operational requirements and architecture. Several high-level operational and architecture planning requirements must be satisfied before implementing an ABAC solution. First, identify the objects that will be shared and protected by ABAC. Second, define the rules or policies that govern their protection. Third, identify and define the subject and object attributes, along with their associated authorities, in coordination with the access control rule developers. Fourth, develop processes regarding how the access control policies are written, validated, and managed. Finally, determine how the ACMs will be segmented or distributed throughout the enterprise and how attribute, policy, and decision requests and responses will be rendered. 3.1.3.1 Object Identification and Policy Assignment. The objects selected to be shared and protected by the ABAC solution will vary based upon organizational requirements. Each object or class of object must be identified, and policy or rules protecting each must be documented. A set of business processes need to be established to identify, class, and assign policy to each new object created within the scope of the ABAC implementation. 3.1.3.2 Attribute Architecture. Access control policies are expressed in terms of attributes. Consequently, all required attributes must be established, defined, and constrained by allowable values required by the appropriate policies. The schema for these attributes and allowable attribute values must be published to all participants to help enable object owners with rule and relationship development. Once attributes and allowable values are established, methods for provisioning attributes and appropriate attribute values to subjects and objects need to be established, as well as an architecture for any attribute repositories, retrieval services, or integrity checking services. Interfaces and mechanisms must be developed or adopted to enable sharing of these attributes. 3.1.3.3 Subject Attributes. Many human subject attributes are typically provisioned upon employment with the organization and may be provisioned by several different authorities, human resources, security, organization leadership, etc. For these, approaches to obtaining authoritative data are well known. As an example, only security authorities should be able to provision and assert clearance attributes and attribute values based on authoritative personnel clearance information. An individual should not be able to alter his or her own clearance attribute value. Other subject attributes may involve the subject's current tasking, physical location, and the device from which a request is sent. Processes need to be developed to assess and assure the quality of such subject attribute data. Authoritative subject attribute provisioning capabilities should be appropriately dependable in regards to quality, assurance, privacy, and service expectations. These expectations may be defined in an Attribute Practice Statement, APS. An APS provides a listing of the attributes that will be used throughout the enterprise, and may identify authoritative attribute sources for the enterprise. Still further network infrastructure capabilities, including the ability to maintain attribute confidentiality, integrity, and availability, are required to share and replicate authoritative subject attribute data within and across organizations. 3.1.3.4 Object Attributes. Object attributes are typically provisioned upon object creation and may be bound to the object or externally stored and referenced. It is to be expected that access control authorities cannot closely monitor all events. Frequently, this information is driven by non-security processes and requirements. Good attribute data that support good access decisions are essential, and measures must be taken to ensure that object attributes are assigned and validated by processes that the object owner or administrator considers appropriate for the application and authoritative. For example, object attributes must not be modifiable by the subject to manipulate the outcome of the access control decision. The object attributes must be made available for retrieval by access control mechanisms for access control decisions. Additional considerations for creating object attributes include: in general, users will not know the values of an object attribute, for example, to which sensitive compartment a given user is authorized. This should be accounted for in ACMs, so that users only see the values that are applicable to them. As with subject attributes, a schema is required for object attributes defining attribute names and allowed values. Attributes need to be kept consistent in DP, MP, and NLP. There have been numerous efforts within the federal government and commercial industry to create object attribute tagging tools that provide not only data tagging, but also cryptographic binding of the attributes to the object and validation of the object attribute fields to satisfy access control decision requirements. 3.1.3.5 Environment Condition. Environment condition refers to context information that generally is not associated with any specific subject or object but is required in the decision process. They are different from subject and object attributes in that they are not administratively created and managed, but instead are intrinsic and must be detectable by the ABAC system. Environment conditions such as the current date, time, location, threat, and system status usually are evaluated against current matching environment variables when authorizing an access request. Environment conditions allow ABAC policies to specify exceptional or dynamic AC rules that cannot be described by subject/object attributes only. When composing ABAC rules with environment conditions, it is important to make sure that the environment condition variables and their values are globally accessible, tamper-proof, and relevant for the environments where they are used. 3.1.3.6 Access Control Rules. In ABAC, all AC rules must include some combination of attributes and allowable operations. They may also include conditions, hierarchical inheritance, and complex logic. Together these provide a rich array of options when implementing ABAC. Rule sets and the application of rule sets to objects must be governed and managed appropriately. Rules must accurately and completely reflect the NLP and be authoritatively developed, some by organizations, some by resource owners, applied, maintained, shared, and asserted. ABAC allows multiple rules from multiple stakeholders. New techniques are needed to coordinate and obtain the proper balance of sharing and protection. In some settings, one might limit the visibility of which rules apply to which objects to limit the likelihood of unauthorized subjects manipulating attributes to obtain authorization. In other circumstances, subjects that are denied access should have a method to verify or rectify the circumstances that cause the denial. Some organizations may wish to track the denials to see if the rules were appropriate. Similarly, rule definition and employment mechanisms and processes should include a robust rule deconfliction, resolution for the different decisions of rules, capability to determine rule conflicts and resolution processes. 3.1.3.7 Access Control Mechanism and Context Handling. The distribution and orchestration of ACM must be predetermined to avoid conflicts and weaknesses in object protection. For example, if an identical object is held by two different organizations, an unauthorized subject should not be able to access the version held by the organization with lesser restrictions. ACMs should be managed, maintained, and employed in a consistent manner to ensure interoperability and comprehensive security. The order in which the ACM retrieves information, evaluates for a decision, and enforces the decision can differ greatly based on the specific requirements of the implementation, and may even take into account environment conditions during access control decision rendering. This is referred to as context handling and simply refers to the workflow the ACM undertakes when gathering the data needed for a decision. Additionally, where and how policy, attribute, and decision information are stored and exchanged throughout the enterprise is an important consideration, for performance and scalability purposes. 3.2 Considerations during the acquisition/development phase. During the acquisition/development phase, the system is designed, purchased, programmed, developed, or otherwise constructed. Typically, during this phase, the organization prepares the business processes needed for enterprise-wide execution and defines the systems to be deployed and integrated. During the first part of this phase, the organization should simultaneously define the system's security and functional requirements. During the last part of this phase, the organization should perform developmental testing of the technical and security features/functions to ensure that they perform as intended prior to launching the implementation/assessment phase. 3.2.1 Business Process Generation and Deployment Preparation. 3.2.1.1 Documentation of Rules. For each of the types of objects controlled by an organization, there should be an accompanying set of access control rules documented in an NLP. Use cases might provide the easiest means for enterprise participants to define NLP for a set of objects. These rules should dictate who can and cannot create, view, modify, delete, forward, and interact with data and services controlled by the organization and under what context or environment conditions they have those privileges. Documenting these rules incorporates the organization's interpretation of applicable policies and guidance, the specific sensitivities of applicable objects, and knowledge of appropriate user communities that will need the objects. Documenting NLP facilitates the development of DP and provides traceability back to the written policy. For example, many organizations have difficulties transitioning their authorization capabilities from ACLs into a more robust ABAC infrastructure because no corresponding NLP exists. As an example, consider that when a request for access is received, the data owner evaluates a set of criteria, usually undocumented, such as, is this person a member of the working group? Or am I familiar with this person or his or her organization? And then renders a decision before adding the requester's name to the appropriate ACL. Well-documented NLPs enable transition from human-generated decision-making to a consistent automated policy-driven access control decision. 3.2.1.2 Customizing policy. Unless required by higher authorities or obligations, subordinate organizations should not make local policies less stringent. If subordinate organizations in an enterprise are able to independently relax the restrictions established for enterprise policy, the security inherent in the system is undermined, possibly allowing local access to enterprise objects where it would otherwise be forbidden. Local access policies implemented in a federated enterprise should reflect the enterprise policy associated with the requested object, based on mapped attributes from the requester's organization. Depending on the sharing agreements between organizations, objects with shared ownership or control should be protected according to the most restrictive policy. 3.2.1.3 Agreement and understanding of attributes. A consistent set of valid values must be defined and applied for enterprise subject and object attributes. This allows authorization decisions to be based on known values that are consistent throughout the enterprise. The lifecycle management of attributes is the responsibility of the provisioning organization, whether the attributes are used exclusively within an organization or across organizations. 3.2.1.4 Understanding meaning of attributes. Attribute service providers need to describe attributes and their relationship with other attributes so that consumers may properly and effectively use attributes. Attribute service providers must document the definitions and meanings of enterprise authorization attribute values and provide guidance on the use of the attributes. In some cases, attributes must be used in combination with other attributes to establish a valid context, such as the combination of role and organization. A role has no meaning unless it is defined within the context of an organization. For example, the director of operations for an entire organization, whose responsibilities may encompass the finance, human resources, legal, and other departments, has an entirely different contextual meaning from the director of operations within the web services branch of the IT department. Without the understanding of the guidance related to the attribute, its context, and the knowledge that these attribute values are required together to render a decision, the DP and hence the decision, may be generated on insufficient information or using faulty logic. 3.2.1.5 Processes and procedures for access failures. A set of procedures and requirements for communicating exception handling, access denials, and errors should be established to provide users a means to remediate access decisions given mission, role, and need-to-know imperatives. As authorization services mature from the traditional method of provisioning an account and populating an ACL to an automated decision process, it will be more difficult for system users to understand and remedy access denials. A well-established process for properly discovering and obtaining the attributes needed for access approval will help ease the transition. This can be expanded to address dropped connections or other difficulties in accessing the authorization service component. In a mission-critical role, the subject should be able to understand the limitations and request an exception, be pointed to an authoritative source of help, or attempt an alternate path to access equivalent information or services. 3.2.1.6 Attribute privacy considerations. ABAC capabilities should be developed to comply with all applicable privacy laws, directives, and policy. Due to the personal and descriptive nature of subject attributes, implementing attribute sharing capabilities may increase the risk of privacy violation of personally identifiable information, PII, due to inadvertent exposure of attribute data to untrusted third parties or aggregation of sensitive information in environments less protected than the originators. Organizations engaged in attribute sharing should employ trust agreements to ensure the proper handling of PII and enforcement of PII regulations. These trust agreements should detail authorized PIAUs and handling for all components in the trust chain, as well as methods for validating, remediating, and adjudicating liability for regulatory infractions. A second consideration is that subject attributes can be revealed by the patterns of grant/deny decisions. If a subject access a particular resource, the subject must possess attributes as specified in the access rule for that resource. The organization should protect access logs or other means of discovering grant/deny decisions. 3.2.1.7 Digital Policy Creation and Maintenance. Each DP should be specified to satisfy the requirements of an NLP. DPs are sensitive and need to be protected in the same way as objects, according to an appropriate policy. These policies may pertain to creation and modification of specific portions of the DP. DPs should be written or modified only by individuals who can interpret NLPs and have authority to write the DP. Implementing a particular NLP may require specification of multiple DPs. Special consideration should be taken to ensure that subordinate policies do not conflict with higher-level policies. Individual organizations should develop and maintain local policy and unique policy that applies only to their constituent or subordinate organizations. 3.2.2 System Development and Solution Acquisition Considerations. 3.2.2.1 Standardization and interoperability within the enterprise. Implementers of ABAC should strongly consider using a comprehensive standards-based approach that enables current-day interoperability and future deployment flexibility by making use of products or capabilities that meet these objectives. An established practice to achieve interoperability and cost-efficient ABAC deployments is to use a series of standards, specifications, and standardized configurations, specifying a subset of standard options, i.e., a profile. Standards that have optional elements may be implemented inconsistently by developers, making it possible for services or applications that are fully compliant with the standard to be non-interoperable. For this reason, well-defined and standardized profiles should be encouraged, especially in cross-organizational environments. When acquiring ABAC solutions, implementers should use commonly agreed upon tailored profiles as well as leverage the standards and profiles contained within existing standards registries. Individual authorization service components, for example, policy decision point, policy enforcement point, policy retrieval point, attribute retrieval point, meet-attribute retrieval point, should be developed with standard, open interfaces so that systems from multiple products can be employed while ensuring interoperability. Enterprises should consider a set of requirements addressing functionality interfaces, infrastructure, and product support to employ as a filter within the procurement process for all acquisitions regardless of categorization or affiliation. 3.2.2.2 Identity Management Integration. A request for access to an object must be authenticated as originating from a unique subject. Authentication is achieved through use of identity credentials, and must occur before an access decision can be made. The ABAC system needs to support the prevalent and strategic authentication mechanisms and credentials used by the organization. This may mean the organization needs to make enhancements to its authentication infrastructure, if its current state impedes ABAC adoption. The subject attributes conveyed in these credentials should uniquely determine the subject, and the identity vetting process used to issue credentials should be sufficient to hold the identified entity accountable. The issuance and vetting processes should be recognized throughout the enterprise as trustworthy and sufficient to enforce accountability requirements. Strong authentication methods should be used that are of sufficient assurance for the request, NIST 863-3, NIST 863-B. Once the subject is authenticated, attributes associated with the subject can be used to determine an access decision, and access decisions can be captured in required audit records/systems to provide attribution of the request. For example, a request transferred via a Transport Layer Security (TLS) 1.2 session with client authentication, RFC 5246, depending on X.509 certificates issued by a trusted certificate authority is associated to the entity bound by the certificate authority to the distinguished name. 3.2.2.3 Support for NPEs. Support for NPEs in access control services has special requirements. Authorization services use attributes associated with entities in any form. The attributes bound to the NPE not only help define the unique NPE but also reflect the context of that entity within an organization. In some cases, an NPE subject may be acting on behalf of one or more human subjects. These NPEs may carry their own identity credentials independent of any human subject. Note that the access control system basing an access decision on an NPE credential will not be able to attribute the request to the individual or individuals who may be acting in that role, or logged into the group account, at the time of the request. NPEs may act either independently or on behalf of an authenticated individual. NPEs may include network devices, for example, switches, routers, processes running on servers, for example, portals, workstations, and other endpoint devices. As mission and security functions are increasingly automated, NPEs will play a larger role as actors in authorization service interactions. 3.2.2.4 Authentication and data integrity between ABAC components. The authorization service requires strong mutual authentication between ABAC components, for example, PEP, PDP, when authorization service components exchange sensitive information. For each exchange, proof of origin, data integrity, and timeliness should be considered. For example, when the authorization service needs to obtain attributes from an authoritative attribute service, mutual authentication should be used, followed by mechanisms for validating message integrity and message origin. Authentication protocols based on strong methods, for example, X.509 authentication, should be used to provide the level of assurance needed by both parties involved in the attribute exchange. 3.2.2.5 Integrating other controls with ABAC. Authorization services alone are not enough to ensure the security needed to protect the mission-critical objects distributed throughout the enterprise. Comprehensive and cohesive security capabilities are needed to establish the desired level of assurance, and they must be tightly integrated and able to seamlessly feed the security information needed for making and enforcing access decisions. These other controls may include subject authentication, security audit, security configuration management, intrusion detection, and monitoring capabilities. 3.2.2.6 Selection and accessibility of attribute sources. Authorities should be clearly identified so that the attribute source is able to provide attributes to the policy decision point from an authoritative source. When multiple attribute services are available, possibly with different meat attributes, such as assurance level, the attribute store/policy information point should balance the retrieval of attributes that satisfy the most restrictive policies, with performance and availability requirements. 3.2.2.7 A shared repository for subject attributes. Direct use of shared repositories for subject attributes should be considered where there is sufficient network connectivity to take advantage of economies of scale, increased quality control, and standard interfaces. Another advantage of using shared attribute repositories is that they provide a single access point for data from multiple sources. Building and managing a connection to a single access point may be less complex than managing multiple connections. In some cases, limited connectivity, insufficient bandwidth, or intermittent connections may prevent authorization service providers from being able to use shared repositories reliably. It may be necessary to maintain local copies of data that cannot be continuously in sync with a shared attribute repository, and thus not have access to current data. 3.2.2.8 Minimum attribute assignments. In some enterprises, a minimum set of attributes may be defined. With a standard set of enterprise subject attributes and object attributes, DPs can more easily be developed and modified to reflect changes in policy. One example of where this approach applies is with classification and compartmentalization markings within classified networks. In most cases, an object cannot be placed on the network without proper marking, and access control policies are written to address the finite and well-known set of classification and compartmentalization markings. 3.2.2.9 Environment conditions. When required by policy, environment, or contextual, information can be fed into the access control process. Examples include threat level, subject/object location, method of authentication, or time of day. The environment conditions may change more rapidly over time than subject and object attributes. 3.2.2.10 Attribute management. Authorities for assigning attributes should be clearly defined and consistent with an appropriate attribute policy. Some form of validation, integrity, and provenance mechanisms, to verify the completeness, allowable values, integrity, and change history of attributes, should be integrated into the mechanism or framework used to manage attributes. 3.2.2.11 NLP/DP traceability. A comprehensive and coherent traceability between high-level enterprise written policy/NLP and low-level enterprise or local DP should be maintained by an appropriate authority. This will enable changes to written policy to be evaluated and subsequent DPs to be altered accordingly. With this policy traceability, the plethora of DPs resident in local organizations will be auditable, verifiable, and alterable given any change to requirements. 3.2.2.12 Rules or policies based on the agreed attributes. If an organization has an agreement with one or more organizations to use a defined list of attributes, some industry and use case specific groupings of attributes are available today. The organization that owns the objects must ensure that it writes access control policies based only on those attributes. Every effort should be made to use any accepted common set of shared enterprise attributes, no matter how limited, to ensure basic interoperability if only to effect a limited secure information sharing capability. As new requirements arise, the enterprise may choose to introduce new enterprise attributes and rules for sharing them. For example, the OASIS ACML Export Control US, ECUS, and an Intellectual Property Control, IPC, profiles serve as examples of domain-specific standardized attributes with generally constrained attribute values. The ECUS profile documents the attributes common to access control decisions for the U.S. Department of Commerce Export Administration Regulations, EAR, and the U.S. Department of State International Traffic in Arms Regulations, ITAR. 3.2.2.13 Externalization of Policy Decision Services. It is common to implement PDPs as services, separate from individual enterprise services and applications. Doing so removes the burden and expense of providing similar decision services for every enterprise service or application, since a single PDP can support multiple enterprise authorization services. Allowing authorization service providers to use PDP services that are provided by the larger enterprise or by the organization greatly simplifies service/application development, saves money that would otherwise be spent on licensing, training, configuring, and deploying disparate instances of these services, and moves operations and maintenance away from individual programs. 3.2.3 Considerations for other enterprise ABAC capabilities. When developing and implementing ABAC enterprise authorization capabilities, architects and program managers must keep in mind that there will inevitably be a long transition from the current access control methods in use now to the desired end state. As standards and technology mature, organizations will need to embrace concepts that enhance interoperability and promote higher assurance solutions while discarding proprietary, stovepipe solutions. 3.2.3.1 Confidence in access control decisions. An access control decision is made by using the accurate, timely, and relevant data gathered from authoritative sources that are appropriate to the level of risk. Confidence in the access control decision depends upon timeliness, relevance, authority, and quality, reliability, and completeness of information used to compute the decision. Other factors in establishing confidence include identification and authentication processes, for example, strength of authentication mechanism, identity vetting, credential issuance and proofing, attestation, source Internet Protocol IP address. When adopting a risk-based approach to ABAC, the factors discussed above should be taken into account. 3.2.3.2 Mapping attributes between organizations. Organizations may name attributes and attribute values differently. It may be important to implement solutions that provide attribute mapping between enterprise organizations to minimize the need for a special class of attributes called enterprise attributes. Attribute mapping serves as a translation between attributes or attribute values that are named differently. For example, one organization may use the name citizenship and another may use the name nationality to refer to the same set of attribute values. In practice, cross-organizational ABAC may follow a collaborative approach outlined in sections 3.1.3.1 and 3.1.3.2. This would allow each organization to make local decisions within a framework that provides assurance of appropriate control between organizations. When new policies are created, if policy authors create or designate their own attributes, policies may not be interoperable. Using pre-agreed attributes will make the policies more uniform and easily understood. 3.3 Considerations during the implementation/assessment phase. In the implementation/assessment phase, the organization installs or implements the system, configures and enables system security features, tests the functionality of these features, and finally, obtains a formal authorization to operate the system. Most of the considerations during this phase are focused on optimizing performance and ensuring security features work as expected. 3.3.1 Attribute caching. When an ABAC solution moves from the prototype/pilot to deployment, attribute caching may be considered to enhance performance. Performance of the ABAC solution can be negatively affected if each access decision requires an across-the-network attribute request. This is especially apparent in low-bandwidth, high-latency environments. In addition to performance issues regarding attribute caching, the organization may evaluate a trade-off regarding the freshness of attributes and the impact upon security. Attributes that are not refreshed as often will ultimately be less secure than attributes that are refreshed in real time. For example, a subject's access privileges may have changed since the last refresh, but those updates will not be reflected in their available access privileges until the next refresh. Environments with sporadic connectivity will need to cache attributes at the local level. The security ramifications of using cached attributes locally need to be determined within the implementing organization at a policy level, and addressed with appropriate technical controls. In these disconnected environments, administrators may employ risk-based analysis as a basis for access decisions, as some attributes at the local, disconnected, level may change or be removed before the system refreshes its attributes. The local and disconnected systems, possible use of stale cached attributes could introduce a level of risk to the system, because the local system is not making use of the most recently available attributes. Therefore, a risk-based analysis may be warranted as to whether or not to deploy this type of solution. An example is a deployed ship with only intermittent, non-ideal connections to enterprise network fabrics. Because the deployed user population will have only minor changes throughout their transit, supporting the unanticipated system user is less of a concern. In this case, a bulk download and local storage of subject attributes may be sufficient for most local access control decisions. Therefore, subject attribute data could be stored locally on the ship throughout a deployment, and local applications and services could use the data from the local store without the need to reach to an authoritative enterprise attribute source. While this is one example of a solution to an austere environment problem, it should not be inferred that this is the only solution. 3.3.2 Attribute Source Minimization. Minimizing the number of attribute sources used in authorization decisions may improve performance and simplify the overall security management of the ABAC solution. Organizations planning to deploy an ABAC solution may benefit from establishing a close working relationship among all of the organization's stakeholders who will be involved in the solution's deployment. 3.3.3 Interface Specifications. To help ensure consistently reliable access to ABAC services, all organizations that participate in information sharing through enterprise ABAC capabilities should fully understand the interface, interaction, and precondition requirements for all types of requests, including attribute and DP requests. It is also important to ensure that as changes occur in the infrastructure and interface requirements, all relying parties are provided notification of updates so they can plan to modify their components accordingly. 3.4 Considerations during the operation/maintenance phase. In the operation/maintenance phase, systems and products are in place and operating, enhancements and/or modifications to the system are developed and tested, and hardware and/or software is added or replaced. During this phase, the organization should monitor performance of the system to ensure that it is consistent with pre-established user and security requirements, and needed system modifications are incorporated. 3.4.1 Availability of quality data. As the information needed to render access control decisions, and in some cases the decisions themselves, is externalized from the objects and consumers, access to information and services will become more dependent on an outside service's ability to provide timely and accurate data. It is important that the infrastructure be robust, well-tested, resilient, and scalable to mission needs. This is important to support attribute services, attribute stores, policy and attribute generation and validation components, decision engines, and meet attribute repositories and conduits through which this information must pass. If outsourced, service agreements should detail availability, response time, and data quality and integrity requirements. For example, failover, redundancy, and continuity of operations must be considered for data and services that are considered mission critical. Maintaining high availability of quality data requires that addition, updating, and deleting of attribute values is performed by trained, authorized individuals, and regularly audited. Formal agreements between providers and consumers of attributes and services should meet an appropriate standard of service, quality, availability, protection, and usage. Various laws and regulations establish responsibilities, liabilities, and penalties related to the appropriate protection of information. The agreements should capture these requirements as well as those related to responsibility for data. Agreements establishing an appropriate level of trust between organizations are important. These agreements would serve to formalize that trust relationship with a series of requirements and, possibly, penalties for nonconformance. APSs and MOS/MOAs for attribute services and authoritative and accountable attribute sources can also serve to translate organizational policy into operational procedures. The purpose, usage, participants, responsibilities, and administration of these services are described in these formal agreements. 4. Conclusion. This document brings together many previously separate bodies of ABAC knowledge in order to bridge existing gaps between available technology and best practice ABAC implementations, and to address the emerging interest in ABAC within the federal government. ABAC controls access to objects by evaluating rules against the attributes of entities, subject and object, operations, and the environment relevant to a request. ABAC relies upon the evaluation of attributes of the subject, attributes of the object, and a formal relationship or access control rule defining the allowable operations for subject-object attribute combinations. ABAC enables precise access control, allowing for a large number of discrete inputs into an access control decision, providing a large set of possible combinations of those variables to reflect a diverse set of possible rules, policies, or restrictions on access. Thus, ABAC allows an unrestricted number of attributes to be combined to satisfy a rich set of policies. This document defines general concepts necessary to understand ABAC. Specifically, it addresses subject and object attributes, and generic features of an ABAC model and its components. It brings to light numerous considerations aligned to the system development lifecycle that must be factored in the planning, design, development, implementation, and operation of ABAC capabilities within an enterprise. The advantages and common pitfalls of ABAC mechanisms are discussed, especially for large enterprises. ABAC capabilities will allow an unprecedented amount of flexibility and security while promoting information sharing between diverse organizations. It is vital that these capabilities be developed and deployed using a common foundation of concepts and functional requirements to ensure the greatest level of interoperability possible. ABAC is well suited for large enterprises. An ABAC system can implement existing role-based access control policies, and can support a migration from role-based to a more granular access control policy based on many different characteristics of the individual requester. It supports the external, unexpected user and provides more efficient administration. However, an ABAC system is more complicated, and therefore more costly to implement and maintain, than simpler access control systems. Appendix A, Acronyms and Abbreviations. Selected acronyms and abbreviations used in the guide are defined below. ASC Attribute and Authorization Services Committee. ABAC Attribute-Based Access Control. AC Access Control. ACL Access Control List. ACM Access Control Mechanism. APS Attribute Practice Statement. CIO Chief Information Officer. CNOPS Concept of Operations. COTS Commercial Off-the-Shelf. DAC Discretionary Access Control. DLP Data Loss Prevention. DoD Department of Defense. DP Digital Policy. DPM Digital Policy Management. FICM Federal Identity, Credential, and Access Management. FISMA Federal Information Security Management Act. GUI Graphical User Interface. HIPAA Health Insurance Portability and Accountability Act. IBAC Identity-Based Access Control. IETF Internet Engineering Task Force. IP Internet Protocol. IR Interagency Report. IT Information Technology. ITL Information Technology Laboratory. MAC Mandatory Access Control. MP Meta Policy. NIST National Institute of Standards and Technology. NLP Natural Language Policy. NPE Non-Person Entity. OASIS Organization for the Advancement of Structured Information Standards. OMB Office of Management and Budget. OPSEC Operations Security. PAP Policy Administration Point. PDP Policy Decision Point. PEP Policy Enforcement Point. PIA Personally Identifiable Information. PIP Policy Information Point. PKI Public Key Infrastructure Readout's Risk Adaptable Access Control RBAC Role-Based Access Control RFC Request for Comment. RLS Row Level Security. SAN Storage Area Network. SDLC System Development Life Cycle. SOA Service-Oriented Architecture. SP Special Publication. SQL Structured Query Language. SEC Trusted Computer System Evaluation Criteria. TD Technology Development. TLS Transport Layer Security. XACL Extensible Access Control Markup Language. XML Extensible Markup Language.